The foundation of quantum mechanics is explained by the following experiment. Suppose we have a wall with 2 holes. Suppose we shoot marbles at it, 1 marble at a time. Behind the wall, we have a cloth. Each time a marble hits the cloth, we mark where it landed. As marbles hit the cloth in the same spot more than once, we mark the red mark darker. Some marbles make it through the holes by bouncing off at an angle. But most marbles that make it through the holes continue in a straight line. After a while, there will be many red marks on the cloth. The darkest red marks will be directly behind the 2 holes. Now suppose the 2 holes are very narrow. Suppose the marble is very small. Now the result is very different. A striped pattern is produced. The marbles never hit the cloth in the areas between the stripes. All particles in the universe produce this striped pattern, provided that both they and the holes are small enough. No matter how many times we repeat this experiment, and no matter what type of object we use to replace the marbles, the result is always the same. Only one known phenomena can explain this result. Waves. When a wave passes through a hole, it spreads out on the other side. If there are 2 holes, 2 waves are produced. When you have 2 waves, they interact with one another. In some areas they strengthen each other, and in other areas they cancel each other out. This creates a striped pattern. This is the exact same pattern that we saw before. This means that all objects really behave like waves. But if all objects behave like waves, then why don't we see a striped pattern for the large marbles? Large objects have much more energy than small objects. Waves have more energy by having a higher frequency. When waves with higher frequencies interact with one another, the pattern is different. Large objects have more energy, and they therefore behave like high-frequency waves. This is why large objects do not produce a striped pattern, but small objects do. But there's still a problem. For a wave to produce a striped pattern, each wave must simultaneously pass through both holes, so that there will be two new waves that interact with one another. But we're shooting the marbles at the wall only one marble at a time. This means that each marble must somehow simultaneously pass through both holes in order to create the striped pattern. Let's see if this is what actually happens by blocking one of the holes. The striped pattern disappears. Most of the marks are now directly behind the one open hole. Now let's block the other hole instead. Again, the darkest lines are directly behind the one open hole. But if we unblock both holes, the striped pattern returns. Areas that were hit many times when one of the holes was blocked are now never hit when both holes are open. This means that each marble really does have to simultaneously pass through both holes to produce a striped pattern. Let's test this by putting a detector in front of each hole. We should expect that both detectors will simultaneously indicate that the marble passes through it. However, this is not what happens. Each marble only passes through one detector or the other, but never both. Also, once we place detectors in front of the holes, the striped pattern disappears. Now the darkest lines are directly behind the two holes, just as when we blocked one hole at a time. Let's try putting a detector in front of only one of the two holes. It turns out that having even just one detector has the same effect as having two detectors and causes the stripe pattern to disappear. Any attempt to discover which of the two holes the marble passes through forces the marble to pass through one hole or the other, and not both. One detector has the same effect as two because once we know if the marble passed through one hole, then we also automatically know whether or not it passed through the other one. A marble goes through both holes only when we are not trying to find out which hole it went through. But when we do try to find out, the marble goes through only one hole or the other.